Hi everyone, welcome back to our course on data structures and algorithms. We're currently in our first unit of study, which is all about arrays. We began looking at how to use an array to create an abstract data structure called a list. An abstract data structure is one where the data structure is defined not by how it's made, but by how it behaves. We're going to be making a list using an array in this unit, but in another unit, we'll use something else. So it's not a concrete data structure, it's abstract. What makes it a list? Not that it has an array in it, but that it allows us to add to the list, remove from the list, get from the list, and see the list. So let's go ahead and take a look at the code that we worked on in the last lesson. We were making a list for storing ints. Here's our constructor and a couple of private variables for the array. We created an add method, and we even discussed how to add a Java doc to make our documentation better. I went ahead and added Java documentation for the other two public methods that we've written. You'll notice that the get and size method both return something, so I added the @return annotation. It simply states that it returns the int value at that index is the get method. The size method has an @return that returns the size of the list. The get method also has the @param, which explains what this parameter index does. We want to use @param when we have a parameter, and @return when we return something. Okay, well, what I want to do in this lesson is I want to go over some of the little bit more advanced methods. I want to start with remove from the back of the list. Let's start with that. So I've got a list here and an array. And to make this a list means that we've got an array and we filled it up with certain things. Let's just pretend that we have, and I'm just making up numbers here, to remind us we don't have to just do one-digit numbers, right? Or even positive numbers. This one could be a 0, and then 1, maybe a 5 again. We can have repeats in a list. We don't have to just have one type, or we don't just have to have a number occur only once. Like the 1s and the 4s, they can occur more than once. Now we know that in reality, there is a bunch of zeros here, possibly, but something is filling these in. But remember, they may not be zeros. They're zeros when the list is made, but we're going to see how they may not always be that way. So right now, this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. So our size is equal to 10, which means that the very next element that we add to our list will go in the array's index of 10. What I want you to do is I want you to write a method, and I want you to call it remove from back. And what I want this method to do is I want it to take the last element in the list, I want it to remove it from the list, and then return it back to the person that called that method. See if you can do this yourself. Remember, it's absolutely essential that you try and write these methods yourself first, because that's what computer science is all about, is solving problems. What I want you to do is I want you to access the element located at the end of this list. Now, our current size is 10. But this last value is at index 9. So this is at index size minus 1. So you ought to be able to find that value in your array. Then what I need you to do is I need you to take the size variable and I want you to simply move it backwards. Okay? Now, once we do that, we have effectively remove that last element because now it's no longer in the size of the array. If we were to loop through the array, or excuse me, a loop through the list, or some other things that we're going to talk about soon, that 4 would certainly not be included. And then on the next item that's added, it'll be written over. So if you haven't tried it yet, try it now. All right, let's go ahead and discuss your solution. We're writing a method called remove from back. Where I place this method does not matter. You probably want to have a good system for organizing your methods. Let's try and follow something more alphabetical, maybe, but a lot of times you'll see methods organized by type. So we're going to be returning the last item. So I'll say public int remove from back. I don't need a parameter for this method because I already know where I'm removing from. I'm removing from the back. Okay, first let's get the value from the back of our list. As we discussed, the size of the list minus 1 is the last element. Now that I've done that, I've got the value. It's time to go ahead and delete it from our list. I'll decrement size by 1. It's gone now. And then I will return the value. So how do I describe the way this method behaves in my Java docs? Should I describe that we've decreased the size and all that? We don't need to go through the details of how it works. We just want to describe what it does. What does it do? Removes and returns the last int in this list. There is no parameter, so we don't need at param, but we do need an at return. What does it return? The int at the end, how about we say the int removed from the end of the list. When you write Java docs, it oftentimes feels like you're being very redundant, but keep in mind that these details appear in different places in the documentation, so it should, if you're doing it right, it should be a little redundant, but that's okay. All right, great. We've done a remove from back. Let's try it out. All right, let's create a new list. And list 1, that's fine. All right, let's add some stuff to it. You know what? We could go ahead and just try and use these exact values here. Why don't we do that? 7, 1, 2, 4, 12. 7, 1, 2, 4, 12. Then what else did we have? Negative 1, 0, 1, 5, 4. And I think I'm getting this right, but it's okay if it's not. I just thought it would be fun to match the little example that we made. Okay, cool. Let's go ahead and inspect it. Remember, our users of our list would not normally be able to do this outside of like an IDE that allows, this is for like debugging and learning, but it's still important that we do that. We want to go ahead and investigate what's happening and make sure that it is the way we expect. We have a size of 10, we expected that. Let's see here. There is our list. Looks like in this case, I haven't expanded yet. I was probably about to expand. We've expanded one time, but we haven't expanded twice. All right. What we're going to do is we're going to remove from the back. So let's do it. Remove from the back. It should return something to me, and it did. It returned a 4. I'm not allowed to get this because it's a primitive. BlueJ only allows me to get and pull things into my workbench when they're reference types, objects, that is. But we can see that it was a 4 that was at the back. And let's go ahead and take a look at our list. Okay, we still got that array. All right, the 4 is still there, right? You can see it right there at 9. But is it really in our list? Well, let's remove from the back. This time it removed the 5. Let's take a look. Again, let's inspect. Okay, our size is now 8, but we know that those numbers are still in our array. In fact, this is really how you delete lots of things from your computer. Whenever you delete a program for a computer, you're not really going in there and wiping it down and removing something. You're just marking it to be written over at another time. So let's test that out. I want to add another number. Let's add the number 99. And let's go ahead and inspect, and let's see. There you can see the 99 is written right over where I last removed. Let's add another one. 100. And you can see that it's added to my list right here at the end. All right, so pretty neat, right? But we need to fix something about our list. So what I'm going to do to show this is I'm going to add another, that's all I'm going to do. I'm going to remove, actually. Let's remove from the back, remove the number 100. And we can see that in the array, it's still there. It's just marked for deletion, right? So what I want to do is I want to access that number. I'm going to try and get, remember we can get a value. I'm going to get the value at index 9. It returned to 100. Well, wait a minute. I don't have an index 9. I mean, 9 is the size of my list, right? As you can see there, I shouldn't be able to access index 9. And so now my list is not working properly. I've tried to access something outside of the size of my list, and I've got something unexpected, right? Other times, I could do this, and I could get a big error, right? Maybe if I try to do, let's try and get something at index 20. Well, oh, boom, java.lang.array index out of bounds exception. Okay, so we're getting problems here. We need to make our list work better, and the way we're going to do that is with something called exceptions. So, new topic, exceptions. They're a class. Just like any other object that you make, you instantiate a class. So we're going to instantiate a class. So here we have get. Well, what we want to do is we want to make sure that this index is appropriate. So we're going to say if index is less than 0 or index is greater than or equal to size, we're going to throw a new exception. Well, we could do runtime exception. And then in quotes, we're going to give a little bit of information. All right, so what I've done is I'm just going to sum the index and then the index they gave us. Oh, got a little bit of a typo there, put the quote on the wrong side. Is out of bounds of 0 to size of, and then I'll give the size of the list. And that's going to tell us that we've done something wrong. Let's give it a try. Oh, I did not close off my curly brace. Okay, cool. All right, let's try it again. All right, this time I'm going to add 2, 3, and how about a negative? Okay. We can see if we inspect it, we're getting a behind the scenes kind of look here. There's our list, 2, 3, -8. And then we have the zeros that are there to fill out the rest of the array because we have to have a default value. Let's try and access them. All right. We're not supposed to, but let's try and access them. I'm going to try and access index 4. Oh, we got a java.lang.runtime exception, index 4 out of bounds of 0 to size 3. And you'll see it's right there. It's printed to our terminal here. Java.lang.runtime exception, index 4 out of bounds of 0 to size 3. And it even tells me the line that it occurred. Super. That's good. We want things to error when we do things inappropriately. But I think we can do better than this because a runtime exception, that's like really vague. Let's give it an exception that makes more sense. Well, there is one. We can choose a more specific exception, and we want to choose a specific exception so that it's more appropriate when people are handling possible errors, because they may want to handle specific types of errors and let others go. Let's deal with something more specific. And that's why in Java language, we have exceptions as this superclass, and then they can be whittled down to more and more specific types of exceptions. So I brought up the Java language API. I just want to go through this. So java.lang.object is the superclass of all classes. Below that, we have throwable. So that's why we can throw them. And then exception, subclass is throwable. Runtime exception, subclass is exception. And then finally, we're going to get more specific here with an index out of bounds exception. We could use an array index out of bounds exception or a string index out of bounds exception, but I would prefer to just use index out of bounds exception, because again, this is abstract. We don't want to specifically be saying that we're dealing with an array, we're dealing with a list. So we're going to use the more generalized index out of bounds exception. Index out of bounds exception. So we are picking the most specific type of error to throw that makes sense. Yes, we could go down to an array index out of bounds exception maybe, but that wouldn't make sense to our users because they're using a list. They don't know that we're using an array. Also, remember, you may not be out of bounds of the array. You may just be out of bounds of the list. So we're going to use index out of bounds exception. Super. All right. One more thing I want to add to this. We're now throwing an exception. We need to alert people of that possibility with another annotation. We're going to say at throws, and we'll say index out of bounds exception. All right. And let's take a look at how that looks on our documentation. So let's run the project documentation. Okay, so we have, there's our remove from back, there's our get, and you'll notice that it says throws. It doesn't just say index out of bounds exception, it says java.lang.index out of bounds exception. Java.lang is the default package that we're always working in, and so we don't have to import something from java.lang. All right, very, very good. I like this documentation. It's looking nice. Okay, so we've discussed so far this lesson, we discussed removing from back, and we discussed a little bit about throwing exceptions. And throwing exceptions is important to making our list really behave like a list. So let's go ahead and add exceptions whenever we need to from now on. Okay, let's add another method. All right, so we discussed how to remove from back. The next thing I want to do is I want to remove from anywhere. So let's just say remove from index. And so if we're going to remove at a specific index, we need to take in an index, right? That makes sense. So we'll put index here in these parentheses. And again, I want to go ahead and make this method return the value that was there. So let's discuss how to do that. So we've already seen that we can remove from the back, and we just move that size variable. And so effectively, when we remove the 4 at the back of this list, we just move this arrow that I'm representing size with, we just moved it back one. And then it's gone because we can't access it. We specifically, I'll make sure you can't access it because we throw an exception if you try to. All right, well, what if we wanted to remove, say, this 12. That is at index 0, 1, 2, 3, 4. Okay, so we're going to try and remove at index 4. So the user is calling remove, and they're putting a value of 4 right here for their argument. So what do we need to do? Well, we are going to send that back to the user, right? So we'll send the 12 back to the user. But how do we remove it? Well, with our list, when you remove the fourth item, or I guess this is actually the fifth item, when you remove the fifth item from like a shopping list, you cross it off. And if you really want to be, nice and you're numbering your list as you go, you would renumber everything, right? So these items here, they need to shift forward. This needs to go here. This needs to go here. This needs to go here. And this needs to go, well, that's actually outside of my bounds, so that doesn't need to go anywhere, right? Then, what do we need to do with size? We need to move size down, right? So let's take a look at what's this going to look like when we're all done. Well, the -1 is going to get pasted right over that 12. And then for a brief moment, we'll have two -1s. Then the 0, we're going to paste it over the -1. Enlarge that a little bit. The 1, we're going to paste it over the 0 that's before it. And we're going to keep going. I lost my size. Currently, size is right here, okay? So we're going to keep going until we reach that. All right, let's take this 1. We already copied it over. Now we got to do the 5, right? And we'll copy it over. And now we're going to stop because we've copied over this 5. The 4 is not in our bounds anymore, right? And we're going to decrease size. Once again, you see we have this issue that we have an unneeded value. There's no reason to write a 0 there. There's our size, blocking it off. Our list is now set to that size. And so, in fact, that last item actually got copied over. So now there's 2 of them, but it doesn't matter. The next time I add something, it'll go right here. So that's how we do it. We remove it, get ready, save it for being able to send it to the user, shift everything down, decrease the size, and then send that back to the user. Okay, so at this point, I want you to pause the video and I want you to do your best to write remove from index. Here are the things that I want you to do. First, I want you to check that the index is valid and throw an index out of bounds exception if it's not. Then, once you get past that, we know it's a valid index. So I want you to store the value that's currently in our list of that index so you can return it to the user. Then, one by one, I want you to copy over everything from the index above the one we're removing down one index. For example, in this, we started index 4, so we started copying at index 5, down to index 4, 6, down to 5. And I want you to keep doing that up until you get to the index that is equal to size. That's when you know you should stop. Finally, decrease size and return the value that you had stored to the user. Give it a try. All right, welcome back. Hopefully you were able to do this effectively. So what I have here is just the beginning of this method. I have int because we're going to be returning an int and index as a parameter, and I went ahead and took care of the throwing an exception. So we're going to throw a new index out of bounds exception if the index is less than 0 or greater than or equal to size. Now, by the time we get to line 50 here in my code, I know that this index is valid. So let's make a value to store this specific thing that we're removing, this integer. So I'll take the value that's going to be removed and I'm going to store it in the value. Now I'm going to use a for loop. I'm going to start my for loop with the variable I at index plus 1, one after where we're removing. I'm going to continue until I reach the size. So in other words, I'm going to continue while this is true. So while I is less than size, and then I plus plus. And what I'm going to do is I'm going to take the array and I'm going to store into the position I minus 1 what is in position I. Okay, once all that is done, all those things have been copied over. And I need to, oops, I put index bracket I, array bracket I. Now I need to decrease the size, very important, or else we're just going to have double in the back of what we used to have. And I will return the value that we removed. Let's go ahead and take a look at it. All right, I'll create an instance of our list, and let's start adding. I'll add a 9, I'll add a 4, a -3, and a 2. Now let's inspect it. Okay, so I have 9, 4, -3, 2 in my list. Looks good. And I want to keep in mind, don't be confused by this length here. This is the length of the array that's backing it. This here, private int size, that's the size of our list. So everything's looking good still. Let's go ahead and remove the element at index 2. And let's see what happens. So I'm going to remove from index, and I'll put in a 2 there. And you can see the size has decreased to 3. The 2 is still there, but now it's there twice. The -3 has been removed, the 4 moved up, and the 2 moved up as well. So let's go ahead and practice adding some more things to make sure that that happens appropriately. So if I add a number, say 99, I should see that extra 2 that was there is now going to be written over. And you can see that it is. Let's see what would happen if we remove the 9. If we remove the 9, that's at index 0. The 4 should move down, the 2 should move down, the 99 should move down, and we'll end up having 2 99s. So let's remove from index 0, which is the same as removing from the front. It removed the 9, like we said. And you can see that it's working appropriately. Let's go ahead and try and access that 4th index and make sure that our error is correct. I'm going to remove from index 4. We shouldn't be able to do this anymore because our size is now 3. But boom, it throws an error, just like we'd like it to. Before finishing off this lesson, let's go ahead and add in our Java documentation. So this removes an item from the list at the given index. Actually, we should say this list. We always use the word this instead of the, which is good style. All right, at param is index, the index to remove, from which to remove. I'll say to remove from. At return, the int value at the index removed, the int value removed from the index, and lastly, at throws, index out of bounds exception. That way everybody knows to look out for that exception because it could happen. All right. Let's check our documentation one more time. Regenerate. There's our methods. We got removed from index. Nice, good Java docs. It works appropriately. Okay. Well, I think that's a good stopping place for this lesson. In the next lesson, we'll look at a few more methods. See you next time.